Hello and welcome to lesson 2 of week 6. In this lesson, we are going to look at nested functions, closures, and scope. My name is Mildred. In the last lesson, we looked at functions in greater details, and we'll continue by looking at nested function. And when we say nested function, it just means that we have a function inside of another function. And one of the use cases of this is to provide encapsulation and hide the function from external access. So the function that is within another function is hidden from the global scope. So using the nested function fashion, let us create a function that adds two numbers. So let's say we have a function called, let's say add num for instance, and this function will take a variable x or a parameter called x. What we want to return is a value from the evaluation of an inner function, and let's call this inner function inner input. So when you try this, just give them meaningful names. For the purpose of this example, I'm just coming up with something randomly. So we want to say that we have a function called add number, which is the outer function. It takes the parameter x. X is now going to be the variable that will be accessed by the inner function. We now have another function inside of this function add num. We call this the inner input y. What we want this to do is to return x plus y, and then we want the add num function to return the inner input. So we want the outer function to return the inner function, and the inner function is going to provide the evaluation of whatever we want to do. So this is just a basic function to illustrate nested function. When we have an outer function and then it is hiding the inner function, the inner function is returned when the outer function is called. What this does is allow us to create functions on the fly. So when we call the outer function, we provide it with an argument, store it in a variable. We are going to look at that in a concept we call closure. Now when we talk about closures, closure just means a function that retains access to variables from the outer scope even after the function has finished execution. Now when you have a closure, it has full access to the variable named in the local scope. In this case, x is the variable named, and the closure has, so here we have x here, which is the value that is gotten from the outer scope. Let's illustrate this before we're able to explain it properly. Let's say we define a variable called closure 1 for instance, and I want this to say add num 10. Now we are calling this function add num and supplying an argument 10. Now this is like we're creating a function on the fly, add num. When we supply an argument of 10 to this one, we are going to try to call this variable closure 1, which is now a function we've created, and supply it with an argument. So we call the outer function with an argument, it returns the inner function, and then we store this in a variable. Closure 1 is the inner function that is returned, which means that we can print closure and supply an argument. So we'll print closure 1, and the argument we supply to closure 1 is 5. It means it's adding 10 plus 5, and the output should be 15 if all is well. Now let me explain this properly. The purpose of this outer function is just to protect this inner function from any outside access. So maybe if there are global variables, you don't want it to access this. Now this inner function is able to access this local variable x. So this is what we call scope. Like when we create a variable outside of a function, we always have it belong to the global scope, and it can be accessed from anywhere. But when we create a variable inside of a function, it is local to that function and cannot be accessed outside the function, but the inner functions can access that variable. This inner function captures the x variable that we have here, allowing us to create new functions on the fly, and these new functions remember the value of add num. If I create another closure to add num 20, so this now should be equal to, when I print, so let's say I print closure 5, it's going to be 25 because 5 plus 20. So the whole concept of closure is just that you have an outer function, you now define an inner function. When you call the outer function, it returns the function as the value. We attach this function that it returns to a variable. That variable becomes a function we can call on the fly. So we can use closure 1 5. We can also call closure 1 something else. Let's say print closure 1. Let's say print closure 1 and want to supply 20. So this time now it's going to be 20 plus 10, which will give us 30. So if all is well, we should have 30 printed. So let me just comment this out so we can just see the value of this when I run. Save this, run, we have 30 printed. So if you practice this over and over again, you will understand the concept of closure properly. And now if there's no need to use closure, then there's no need to use closure. One of the use cases is just to provide that encapsulation when you want to hide particular function from outside access, like that. Okay, so we just talked about scope a while ago, and when we say scope, we just mean the place or the access level of different variables. If we say, for instance, x is equal to 2, this is defined outside of any function and it is global. So all through this page, x can be accessed. When you call x, it knows what x is. Let's say I define a function called power, and I say power y. And what I want to do with this is to return x raised to the power of y. So every time I call power, within this function, power knows the value of x because it is global in scope. So when I print power of 3, I will get 8 because 2 raised to the power of 3 is 8. So I'll clear and run, and then we'll get the value of 8. But if I decide to print y, this will result in an error. Maybe we'll have a name error. And the reason we are going to have this name error is that y is not defined outside of the function. Y is local to the function. When this function is not called, the value of y is not known. And when we try to run this, Visual Studio Code already shows us that it doesn't know what y is. When we try to run it, we'll get a name error, and y is not defined because y is within this function and it is local to that function, and outside the function it is not known. So this is where we end this lesson. Thank you and see you in the next lesson.